In this video, I want to give you guys a bit of an overview of pointers and how pointers are not much different than regular variables when you talk about them in terms of where they are in memory and their values, which I think will help you guys understand pointers a little bit more. And also we'll go through an example of some of the Lab 0 that you guys were working on in order to assess or analyze what's happening with the pointer information, what's happening with the variable information, in order to see why some char swaps are bad and why some char swaps are good. And hopefully what this will give you guys is a bit of understanding of pointers kind of at a high level in terms of what's happening in memory, which will help you a lot with exam questions where you're asked to analyze the contents of memory, and also later on debugging some of your code when it's not working as you would expect. So what we'll do here is we will look at each variable, or look at each line and see what's happening. So, starting with the first line here, char C1. One thing to always keep in mind is that every variable, no matter if it's a character, if it's an integer, if it's a pointer, every variable exists somewhere in memory. It has a name. This one, for example, is at memory space 01, and it'll have some sort of value in here. So a variable exists in memory at some location, has a name, and has a value. So similarly, going on to C2, C2 exists somewhere in memory. Say it exists at 0x2, and these don't have values yet, or we can't rely on the values inside of them because we haven't assigned anything to C1 or C2. Now C1 pointer. This is written, I wrote it a bit differently here than in your lab manual, but this is what makes more sense to me. So what you can basically do is you can put this star either beside the char or beside the variable name, but I like to put it here because what this is telling me is that it's a pointer to a character. The star is associated with the variable type, a pointer to a character. So exactly like with C1 and C2, C1 pointer will exist somewhere in memory, and it will eventually have a value, and we'll see that this value is what makes it a pointer. And then C2 pointer also exists somewhere in memory, and it'll have a value eventually. So we've set up our variables. We've seen that they exist in different spots in memory, and they don't hold anything yet. So going on to the second part here, C1 equals A. So what this means is the value of where C1 exists, we set it to the character A. So we set this to A. And then C2, we set it to a value of B. Now, here's where pointers differ from regular variables like characters and integers. Is C1 pointer is equal to ampersand C1. So what ampersand means, it means by reference, but more colloquially, it's the memory location. So we're saying that the value of C1 pointer, so in here, we're going to assign to where C1 exists in memory. And in our example, C1 exists at 0x1. So C1 pointer is going to be 0x1. And then similarly for C2 pointer, it's the memory location of C2. So C2 exists at 0x2. So what we put here is 0x2. So that's all it really comes down to. Each variable, no matter what type it has, exists somewhere in memory and it has a value. So let's analyze bad char swap. So the way that we would call this is something like bad char swap, and it takes two characters, so we would give it C1 and C2, and this is what happens in your lab. So when you're dealing with functions, one important point to make is that whatever you pass in our case C1 and C2, its value always gets copied to the parameter. So in this case, V1 is a variable, so it exists somewhere in memory. And and the value of C1 gets copied into V1. So A gets copied into V1. Similarly, V2 exists somewhere in memory, and then the value of C2 gets copied into V2. So that's B. Okay. So, looking at the first line here, char temp, so what we're doing is we're creating another variable, so it's in memory. Going to the next line, temp equals V1. So what this means is that the value of where temp exists is equal to the value of V1. What's the value of V1? It's A. So the value of temp is A. Now we say V1 equals V2. So V1, the value of V1 is now going to be set to what V2 is. And then V2 equals temp. So V2 is going to be set to what temp is equal to. Now, when this finishes, how can we tell that it's a bad character swap? Well, we gave it C1 and C2, so we expected C1 and C2 to change. C1 to be B and C2 to be A. Obviously, as we track what happens in memory here, we can see that the values of V1 and V2 change, but C1 and C2 don't. So this is a bad character swap. And I'm going to scroll down a bit for 1 second because I want to kind of bring to light another notation of writing things. So often you'll see instructors or tutorials online say that, or draw it kind of like this, where C1 pointer points to C1 and C2 pointer points to C2, and then you can update these pointers like this. You can do it this way. For me, it's a little more confusing because it's not completely clear that C1 pointer is in memory, and it can just get a little bit hairy if you start having lots of pointers pointing to different spots in memory. So what I would recommend is don't use this. Track what's really happening down in the memory level with your variable names with values at specific locations. So the last thing that we'll do here, I'll get rid of bad char swap example, because once you're out of a function, all of its variables get deleted. You don't use them anymore. And what we'll do is we'll look at good char swap. Sorry that this is scrolling down. So good char swap would be called like this. We'll notice that good char swap takes a pointer to a character, so we would give it C1 pointer and C2 pointer. And then that would be passed into V2 and V1. So V1, much like every other variable, exists somewhere in memory, and V2 exists somewhere in memory. And what we pass in are C1 pointer and C2 pointer. Now, even though it's by passing the pointers, the values are still copied. So what's the value of C1 pointer? The value is 0x1. So it's this value that gets copied into V1. And same for C2 pointer, the value of that gets copied into V2. So we have temp again. It exists somewhere else in memory. And going on to the second line here, temp equals star V1. Whenever we're using a pointer, so V1 has already been created, so we're using it here, we call this operator a dereference operator. So what's happening is it's saying that I know that V1 is a pointer, so I want to dereference to where it's pointing to. So this will make more sense with this example. So what we're saying is the value of temp we are going to set to the dereferenced value of V1. So where does V1 point to? Points to 0x1, right? Which is C1 here. What's the value in there? It's A. So that's what temp gets set to. Again, dereferencing is going to the location that the pointer points to, or the address that the pointer stores, and copying that value. So then when we say star V2 equals star V1, it's the value where V1 points to, so 0x1, gets set to the value where V2 points to, 0x2. So this ends up getting the value of b. And then going on to the last line here, the value of where v2 points to, 0x2, gets set to the value of temp. The value of temp is a, so this gets set to a. Now when we finish and return out of this function, we see that C1 and C2 did indeed swap their character values. And the way that we stepped through that is by copying over the values, the pointer values, into the function. And you can see nothing really happened here, but the important part was that we had stored where those original character, like C1 and C2, where those existed in memory. And then we could use that pointer variable in order to go and set the value of that original memory location. So I hope this was a little bit helpful for pointers. Feel free to chat with me. You can send myself or Brendan an email if you have any questions, and we'd be happy to chat with you during the lab sessions. Good luck!